Hi all, here is your Diffusion Lab walkthrough. It is for lesson 3.10, and the definition of diffusion is the movement of molecules from an area of high concentration, or an area that's very dense, to an area of low concentration where you wouldn't find many of the molecules. So the simplest example is if you take a clear glass of water and you pour Kool-Aid in it and you just pour it in, you don't stir it at all. Over a period of time, what's going to happen? The Kool-Aid will end up dispersing itself fairly evenly throughout the glass. That's diffusion. It just takes place without any additional help. Although sometimes different types of diffusion will require help or energy. We'll get into that another time. So, lesson 3.10, you start the lab, and I have to warn you, any of these labs in bio, if you don't do the tutorial, it's so difficult to figure out what to do. It's a really frustrating experience when you haven't done the tutorial, in this lab in particular, but I would really say most of them. So please do the tutorial first. We're jumping right into the lab, so here we go. I have made a document with the procedures, as you can see right there, and I'm going to send those to you. These procedures you can find on page 6 of 9 in that lesson 3.10, which is the lab. However, they were kind of buried in there, so I just kind of pulled them out for you. Moving on. Okay, so our first step is to pick up one of these pre-cut cubes. And if you look, this is a 1 centimeter agar cube. These are 2 centimeters, and these down here are the 2.5 centimeters. So they've already cut them for you, and I will show you also your data tables. Here they gave you the sample ones, and we'll go over this in a minute. But you're supposed to write down how many sides each cube has, which it will always be 6, and the length of the sides, and we'll do those calculations later. Alright, so back to the lab. Pick up one of the cubes. Let's just start with the 2 centimeter cube just for kicks. And in order to do that, you click on the spoon. Okay? And just click on one of the agar cubes. Oh, okay, I guess we're picking up the 1 centimeter one. And you're going to put it in the beaker. From that point, we have to put the spoon down before we can do anything else. And we're going to move these arrows a little bit so we can pick up with 2 hands our beaker. Oops, come on. And click to let go. The next step it tells you is to pour in the vinegar. All you do is a click and it automatically pours the correct amount. Isn't that nifty? If you notice, if I tried to set the vinegar down here, that not possible sign, it won't let you do anything when you see that little arrow. Okay, now what we're going to do is we're going to set our clock. And if you look at your data table and your procedures, it's asking you to do the first trial for 5 minutes each. So we're going to set this for 5 minutes, and then you have to start this agitator. I'm going to start the time and start it here. Alright, and what we're waiting to see is the vinegar, which is a weak acid, will end up moving into the agar block. And the agar block has an indicator, which you know what an indicator is now. A red indicator called phenolphthalein, which is one of my favorite words, because it looks funny when you try and pronounce it. Anyhow, the phenolphthalein is an indicator for acids. So as this cube is being bounced around inside the vinegar is going to interact with the phenolphthalein molecules. And when phenolphthalein detects an acid, or a weak acid like vinegar, it will turn clear or colorless. Alright? So what we should be seeing is some of the red turning clear. Alright, and so what we're going to end up doing is measuring the extent to which the vinegar has moved into the agar cube, the extent to which the molecules are interacting with each other. Okay, so this takes place in real time. So I'm going to pause the recording and come back just before it's finished. But to you, it'll seem like I'm only gone for a split second. So I will see you in just a minute. Okay, the timer, 5 minutes is almost up. And as you can see, much of the red indicator has been colored, well, changed to clear. And we're going to stop this in just a few more seconds and continue with the procedure. Okay, stop. Now what we need to do is we need to, oh, I forgot my spoon. Take the spoon, we're going to take the agar cube out and click to place it on the paper towel. We have to put our spoon down. Let go of the spoon. Okay. Come back over here. We're going to pick up this other paper towel and we need to blot the agar cube. Alright? And then we set it down. The next thing we need to do is pick up our scalpel, which I believe is over here as well. There it is. And we're going to bring it back over here and we're going to just click on it to cut the agar cube in half. The next thing that we need to do, you're going to have to zoom in closely if you're going to get an accurate measurement. So zoom in as much as you can. We're going to use the ruler here. Oh wait, I gotta finish zooming in some more. This is going to be helpful. Take our ruler and we're going to try and measure how far in the vinegar molecules traveled. So I have the centimeter mark, the 0.0 centimeters on the outside of the agar cube, and I'm looking for how many millimeters in do we see the red begin. So if I'm looking at it, I'm looking at between 3 and 4 millimeters. The vinegar has moved in to the agar and changing the indicator to a clear color. All right? I'm just doing it on the left cube. Okay? You could do it this way too. Again, lining up the 0.0 on the longitudinal side, the long side, with the outside of the agar cube, and counting how many millimeters, those little tiny slash marks, until you see the red. So again, it's about 3.5 millimeters, okay, which is a part of centimeter. So you could put just 0.35 centimeters. 0.3 or 0.4 centimeters would be considered correct answers. Okay, you don't have to get it. You don't have to be 3.5 or anything like that, or 0.35. Or you could put it in millimeters too, but make sure you use the correct placement for the decimal point. Millimeters would be 3.0 millimeters. Okay? Now, we'll zoom back out here for a second after I drop this down. And now we need to continue with the rest of the lab. You'll do those same steps for the other cubes of agar. But right now we need to figure out, okay, well, where are we going to put this information? If you look on page 2 of your lab, data table 4, part A, 5 minutes start time. The length of side of the cube was, this is our 1 centimeter cube, and you'll write down how far the distance the vinegar diffused. So if you're using centimeters, you would put 0.3 or 0.4 or whatever you get, but you could use my numbers, 0.3 centimeters. All right, and then it asks you to do the diffusion rate. So the calculation for the diffusion rate is simply you take your 0.3 and you divide it by minutes. I'm sorry, this is millimeters, so we're going to say 3.0 millimeters and divide it by the minutes. And that is your diffusion rate. So you'll do that calculation right in that box there. One step that I want to go back to do with you really quickly before we move on is this. They did a sample to show you what your data table here should look like. You should have 3 data tables, I believe, for each size cube. The surface area of a cube is always going to have 6 sides, so here you would simply put 6. The length, and this is for their sample cube, okay, they have the length at 4 centimeters. For cube 1, our length of the 1 centimeter cube is 1 centimeter. The width of their sample cube was 4, our width is going to be 1. Alright? And all you do to get the surface area for the cube is you multiply these 3 numbers. So for our actual 1 centimeter cube, 6 times 1 times 1 is 6. Okay? Very simple. Length, all going to be exactly the same for a 1 centimeter cube. So we're going to have 1, 1, and 1. So the volume for the cube is going to be 1 cubic centimeter. Finally, you take the surface area number, which we came to find it was 6, and the volume, which we came to find, which was 1, and you're just going to divide those. See that what they do here, surface area divided by volume? You're going to divide those. 6 divided by 1 is 6. Okay? So that is how you do the calculations for these. All right. For the remainder of the lab, you're going to do the same steps again. So all you're going to do is pick up another cube, this time one of the bigger ones. We're going to put it right in here, and you're going to set your timer again after you drop your spoon for 5 minutes, and hit start. Oops, start. And you'll do the same things again. When the time is up, you'll lift it out, place it on the paper towel, blot it, cut it, and measure it. All right? Now, the second beaker here is for when you do, either I think the 10-minute labs are what you do next. And I think there's also an option to do the different shaped labs as well, or the different shaped cubes here. So read through your directions. Let me know if you have any questions. Complete all the data table stuff. And just explain simply what you saw in your analysis questions. It says record your observations of the cubes, what they look like before, what they look like after. Very simple. Don't overthink it. How did you know that the vinegar diffused into the cubes? We talked about that. Answer those questions the best of your ability. And when you get to the making graphs, I'm going to send also an example of the making graphs. So you can use my example with your own numbers. Okay? Have questions? Don't hesitate to contact me, and I will see you soon. Have fun.